Okay, so hello. My name is Noam. I'm an architect at Wix. I've been working in Wix for the last 5 years or so. And today we're going to talk about server-side rendering, the process of moving our client-side render to server-side rendering in Wix. And although some of the issues that we'll handle, some of them seems maybe simple or obvious, but when I got to this project, this is, by the way, one of the reasons that I choose this quote, that we had a few attempts of trying to move our code from client-side to server-side. Some of them were partially successful, some of them were not successful, and when I joined the effort, it was something of, it was not sure that we're going to succeed, but we tried anyway. So a little bit about the agenda today. We're going to do a short intro. We're going to describe the changes we did in the client, then later on in the server, and conclude there. So why did we start client-side rendering? Why did we, like at Wix, we had a conscious decision to do that a while ago. And we did it for a lot of reasons, because it was simple. There were no CPU-intensive tasks on the servers, so we needed a lot less servers to start rendering a website. Also, when we had difficulties in downloading resources, we used the external CDN, so we didn't have to maintain all of that throughout the websites. And also, one benefit that we had is that client versions were just a string. So I'll touch into it a little bit later, but remember this comment, because it gave us a lot of flexibility when we wanted to test stuff and when we wanted to upgrade stuff. So we had client-side rendering, everything was great. Why did we change it? We didn't change it in an early life cycle of the company. We changed it a few, like 8 years since the company was founded. So client-side rendering worked for us a long time. And we changed a lot of things throughout the years, but basically we still kept it rendering in the client. So SSR, I think one of the key benefit that we tried to solve, there was a lot of talk about dropping support for Ajax scrolling, and that would have ruined our SEO. And eventually it didn't happen, but there were some talk about small companies like Google that were going to drop Ajax scrolling, and since our site was dynamically built, that would totally kill all of our websites. Another thing is that a new kind of machines started to rise. They're called mobile. We all hold it in our hands, and they have less resources than a computer. Rendering stuff on the mobile side started to show some cracks, and load times were increasing. So this was the second thing that we wanted to go to SSR to, because the project goal is just, replace the old infrastructure, do it gradually. So this is actually every project that you want to do. You want to have it replaced, and you want it to be able to expose it gradually and not do it like if you stumbled across a project that you had to go to either 1 or 0 and you don't know, you're not sure about what happens when you're switching, when you're flipping the switch, you're doing something wrong. So basically this is one of the key requirements for every new project, but this was especially a requirement for us because there are a lot of developers working at the current time and back then on the same code base. So when we have all of Wix working on top of the infrastructure, developing and releasing features, and we didn't want to introduce another hop that they had to go through. We didn't want to damage the velocity that they had. Right now, developing so many features for so many websites and so many users is a lot of a developer has a lot of things to keep in mind, and server-side rendering, we want it to be as transparent as possible, at least as a goal. And another thing, the last thing was just like, don't break anything because, well, this is the company. So we're trying to replace the infra of the company beneath its feet without breaking or causing any downtime. As far as I can remember, we didn't kill the website, or maybe we did for just a small time, but it wasn't directly related. What are the timelines? When would you start? We started about like January 2017. We started opening to users in May, and we fully deployed it to mobile devices at 2017, and then we started working on desktop. And I think, as far as I know, we're starting to roll out the desktop version as well right now, as we speak. So the project is keeping and instead of waiting for you to wait the entire lecture, the graphs or what we got. This is a newer release, new graph. It actually in the mobile the numbers were much better. I'm not allowed to show you any numbers, but if you can see, in 90% of the times we had a 50% drop in load time. In mobile, it was even 70% and sometimes 80%. It was a very large and significant change in the load time of Wix pages, and it was very successful. A little bit about the client architecture that we have. When we had client-side rendering, if you can see, if you know what happens is that the server, we're accessing the server, we're getting a bootstrap script that have like all of the points and references to the scripts and the user data. At that point, when the scripts are fully loaded, you'll see a blank page. Most of you won't notice it because you think the website is still loading, but the website is not still loading. It's already finished loading the initial HTML, the index HTML, and now it starts to download Santa, which is our client in Wix, and also user data that was packed, that is also remote. Once you get those two, it can start React rendering, and when the React rendering is finished, the site is being set to visible, and then you can see it. So this was the old architecture, and it worked really nice. If we look at servers, metadata is sitting on our servers. We serve it. And the rest is sitting on the CDNs, and we have still fallbacks to our data center, but basically everything is CDN'd, except the initial script. After, what was changed in the load time is that the server, of course, renders the first initial script, but it also contains the rendered site inside of it. There is one more significant step, which is the warm-up state. And once we finish the warm-up, the site is visible. Once the site is visible, we still keep on loading the rest of Santa and keep on doing the same render. And at the end of it, the site is fully functional. But if you go into a Wix website, you see the results much faster. So the site after the warm-up stage is partially functional, but not fully functional. But yet it gives you most of the things.
It's mostly functionality issues, or maybe below default, or other things like that.
No, it's mostly. Great question. Next slide. The warm-up stage. The warm-up stage. Why is this faster? First of all, it has a lot less things that it handles. It's smaller than the code base of our client, so it's 700K instead of 3 megs, minified, and
easy.
not easy.
I just want to know the numbers that you see up there are not GZIP. If we looked over the wire, It's actually over the wire. It's 700K for the client-side rendered versus approximately 250K for the server-side rendered.
So why do we have the warm-up stage? The warm-up stage is there because there are a lot of concerns inside in the client that are very obvious for client developers, as like layout. What is the size of the screen? We don't know that on the server side. There are some things about loading images, and also once the site is loaded, it can get post messages from iframes and stuff like that. So we have to bring those listeners up. So this is what actually happens on the warm-up stage. I added like this small thing is that right now we have a project that we want to eliminate that phase and have it work without it. But when we finish, I think we'll have another lecture to show you guys. So, yes, sir.
What is the state of the site when you've loaded versus when it's interactable? Let's say clicking a link or any JavaScript interaction.
Oh, so the question is, what is the state of the site once the site is past the warm-up stage? Well, first of all, it is functional. So if you click on links or images, it will work. Some of the, let's say if we have an external iframe that shows, let's say, our ecom solution, it will already start to load and it will be fully functional inside. Still, I want to talk to you about challenges of the client, at least the client encountered and we encountered with them. The first one, I think the biggest one, and it's still holding on, is the mental one. Developers write code. They do stuff when they are used to working in the browser. For example, accessing the DOM. In the server, you don't have a DOM. So writing code in a way that it would work on both platforms, client and server, it takes some time to adjust to. At first, I think when we initially started, we had our client version breaking every day. Then we start adding tests and adding some more restrictions for people to realize that something is actually working on the server. So we had a test that people were accessing, like we're calling, at first they wasn't aware that it was working, and then they were breaking it. And once they broke it, they go like, okay, what changed? And then they had to go and fix their code again. So this was the first mental thing. Another thing is, and I'll touch into it a little bit later, is that now rendering happens more than once. If you're in the browser, you have just one render on the same VM, and when you do it in the server, you do it multiple times, and that introduces a lot of things that are changing. Another really significant mental change is that when the code is running in the server, it has a lot of other things that are affecting. Like, for example, bad code. If you write bad code or some bad script that's causing some crazy stuff, you can cause downtime for all of the website, not just like specific site with specific component. So we had one time when there was this bug with Node that with the library which was using, that was causing buffer overflow, or it was extending the buffer that the library had. Once that happened, Node apparently just kills the process and doesn't tell you anything. And I just like hit it accidentally before I went home, where I just ran like maybe 20 or 10 calls, and all of the rendering servers were dead. For each request getting to a process would kill it entirely, and then after like a very low number of calls to the Node server, all of the cluster died. So this is something that when you write client code you don't even consider, but those things can happen. Another thing is that if you if you damage performance, you increase the number of servers. So if you have a code that is cheap, that is more expensive in 20%, and you had 100 servers, now you have 120 servers. It's not just affecting a single browser or a single website or a single anything. It will affect all of the websites.
Question: when you say no DOM access, for example, popover and hints and everything, do you use DOM access? So can you use them in the real render, or you just
You
find
can
a way around it, or you still can use the DOM, it just can't be rendered statically?
when you I'm not sure I like maybe
Take for example the portal, for React portal. I don't know if you use it. You need to create a DOM element, and you need to add it. You actually go outside of the boundary you just mentioned.
so our
Eliminate client side. Yeah, but
so what we try to do at least is that the render itself gets all of the. There are subsequent renders that will do that. For example, things that are very client-oriented, maybe size or this would be taken from the client. But the component themselves, like a component cannot go like, okay, give me a DOM, get length or whatever. It need to get it in props. So this is actually the common practice when you write React components. But still, not everybody is doing it. And when they do, we had to fix a lot of code to make this thing. This is actually a great question toward my next slide, which is what do we do with state? Like, for example, the common practice is to use pure components. In server, when we have a shared VM for everything, if you have a component that stores a state, for example, stores an experiment turned on or turned off. Once the code is being run once, that thing is staying for the rest of the renders. So, for example, if we had an experiment that says, okay, show this button in blue instead of in yellow, first render sets it to yellow or blue, and that's it. The button is constant. So those things is very easy to see, but still, we had to go and fix it backward. Another thing is, don't write stuff to global. If you write stuff in global in React in a browser, well, that's just that specific tab that won't. I don't even think you have global on the client. Yeah, you can do like sort of things, but when you do it in a Node server, that would be there for the next render. So if you set something on global, then the next time you query it, it will have the previous value. It's not very nice to see that. And this is actually a thing that we had, a problem that we hit. We had some cache or some in some of the components, someone introduced a cache. That cache would fill up, and after like 2 hours, we had out of memory exception. The servers would die and then start again. We also had to fix that. So if you don't have to do that, don't do it at first, but in the first place. But this is what happens. But this is explicit state. This is what you do. This is what you know that you do. The implicit state is something that is more tricky. So, for example, you see here a code that does imports, let's say, our experiment system. It gets active experiment and it returns it. This code, if you import it in the client, that would work great for you because the client would still keep on returning the same value. When you do that in the server, you do only require once, and once you require it, the code, everything is stored as a state. So next time you do the require, it won't reload the values. It won't change the value of current. It will still have the same values that before. This is something that you don't consider a lot, or you don't hit a lot when you do when you write in the client, but still, this is something that we had to discover, and we tried a lot of like things to do automation for it, but eventually we had to just go and test each component. The second thing is, if you look at this code, it's the same function, current equal the experiment system value, and it returns current. This code is actually worse because when you don't write in Node anything before the variable, you automatically store it to global. So this one was also accidentally will cause like an implicit state to be stored. This current issue with client is being solved by lint, but and at first we had some in the research stage I started like experimenting with running code multiple times and test if it stores stuff. I actually managed to find ways to do that, but we didn't need something that education proved to be a lot better in educating developers not to do those kind of things. The last one of the important thing is what we call diverges. Diverges, once you heard that we do render on the server and render on the client. If the renders are not equal at the end, the React will drop the our render and re-render and use the client render instead. This happens for many reasons. Like for example, if you generate random values in your code and then you re-render it and regenerate another random value in the client or using timestamp, this will cause different. And once React realizes that the DOM is different, it replaces everything. So it's not very good. And then you see a flicker when you see the site. Another thing, timestamps or time or anything, any component that changes, the render has to be equal on both sides. One of the good news is when we started, we didn't have React 16. React 16 has hydrate, and it actually React 16 has a lot of improvement for server side. Had we had it back in the day, it would have saved some time or work, but still. Right now, to do like randoms and time state is we store that data in the server and then it's being downloaded again to the client. And once it's downloaded to the client, we don't do a randomize and we don't get the clock value again. We get the value that was rendered on the server. Dependencies. Now, client dependencies are server dependencies, so you cannot, there are some things that were very simple, like for example, you could have upgraded the React version for just one website or just one page. As I said earlier, the version is just a number that you change on the page. This is something that we can do now, and it's all upgrades needs to be synchronized. If you render stuff with the React may be saying that it's going to be equal, but usually it's not. So those things need to be like carefully considered, and all dependencies need to work on the server. So now we don't have just the client side; we have the whole company working, and we still need to have everything play together. So if you're using a library that someone developed on another team, it should do the same thing as others. So it was easy to educate like the circle that sits around me, but there are some people who are not sitting around me, and they break stuff, and then we had to at least contain it at first, and later on fix it so it won't happen again. And then I'll go to the part that I'm more in charge of, which is the server. The server itself, as I showed before, you're accessing our servers, you're getting the index, you're getting the bootstrap script, and everything is loaded from the CDN. Simple life for us. We don't have to do a lot. SSR architecture wasn't changed a lot. We just added a Node.js server. There are some changes inside. Some of them are more complex, some of them are less complex, but still, everything was built like on top of other, and right now, if we look at the new architecture, then the website calls our servers again, but this time that our servers are accessing Node.js server, rendering the content, returning the response, the data, the metadata, and the scripts are all sitting on the CDN. On the server side, I'll explain a little bit more where we get the scripts and how we do that. But the changes in architecture were not very significant. Yes.
Why wouldn't your site just call the node, which would call your server in return?
Another great question. The first answer is that the change needed to be gradual. And changing such significant thing in the architecture would have been very difficult. And I think the first decision, the decision, if you can see the architecture, we did do a lot of things. Like, for example, only supported sites were being rendered. So at first we had targeted the mobile, so only mobile devices actually got got the server-side rendering. All of the other things in the system just didn't know that anything was happening. Another thing is that I think this is a very important thing for everything you develop: sustainable defaults and fallbacks. We introduced fallbacks, I think, in every level of the system. And when you have good fallbacks, you can sleep better. And I like to sleep, or at least party at night. And you don't want to get like this call at like 2 a.m. That you need to handle something after you got back from a club or something. So we had fallback on the server. So if the node was not answering properly, it would have been fallback into the client. We had in the client itself. So if the client was trying to get a response, it wasn't getting a response, it would fall back to the client one. And there were timeouts in everywhere. So if we were trying to deploy or add support to a specific component, we just opened it for a certain percentage of the traffic, and if it was working, then great. If it wasn't working, we were closing it. The users, on the other side, in the worst case, they would have seen like a delay of another extra second. So I think this decision was one of the keystone in actually being able to replace stuff, because you don't want to, I think this is a tip that I can give every developer. If you want your name to be known, come and kill the main, cause a downtime for 5 minutes in production. Once you do that, everybody knows your name. But the bad thing about this decision is that you don't want to do it more than once. You just want to do it once so people would know you, and then you can continue on. And introducing fallbacks and causing downtime in Wix is something that is not recommended, because once you do that, you have a lot of people nagging you, and not the people that you want to be nagging you. So let's start. The server, the rendering itself. The rendering itself, one of the things that everybody thinks about React, they go like, okay, it's React, it's JavaScript, great. Node runs JavaScript, great. Oh, that's a good match. Everything is working. But it's not working. Node is a single-threaded as the browser, and React render is very CPU intensive. So what happens is when you render one site, Node is actually it's basically down. It's not answering anything. So it's not such a great fit. The way that we handle it is that we are actually, each server have like a router process, and we're using a library to actually distribute it distribute it between processes. So if render request is getting, one process is handling it, and the main process is getting more requests and also assigning it into other processes. We used an open source library, and I don't remember if I wrote the name. You can ask me later on. But using that specific decision allowed us to actually serve the traffic in a way that was sustainable to a high load. Also, it allows us to introduce a lot of other features. Well, I'll discuss it in other bullets. Another thing is that once we started deploying it into our servers, we started getting, at first we wasn't aware because we were playing with a single server and it was very CPU intensive. And later on, some guy from system told me, oh, you're using that server, because a lot of processes were complaining that other services that were sharing our servers were complaining that their servers are not responding, they were getting a low response rate, because we were actually consuming all of the CPU in those systems. So this one was every unfortunate service that was using the same service as we did at first, at least in the development stage, just moved away from there by itself, because you realize that we're not very good neighbors. But one of the things that we realized is that the servers does more tasks like monitoring and BI collecting and a lot of system tasks. And if we consume 100% CPU from 4 cores, and the system has 4 cores, then the system is not responding, even to SSH, by the way. So even if you're trying to access it and kill something, or the server was not responding because it was too busy. So one of the things that we decided at like the first, after we realized those things, is that we are not touching a specific core. So one specific core is being saved for system tasks, and we're handling the rest of the cores for rendering. When we start deploying, we start calculating the number of servers, and I think we got to like a large amount of money, and we tried to save a little bit of money. We had so to do that, we tried to squeeze as much performance of each server. And one of the things that I realized using when I tuned the servers is that if you're allowing Node to render on each process whatever it wants, then the tasks are jumping from core to core. So one of the things, the first thing, and it works okay, like on the first core you can get maybe even more than one core can handle, but on the second one you see the decline in performance, and you're not scaling linearly. When I pinned each core to a specific renderer, when I did that, performance started to stabilize. So the switching between cores is very expensive, and it helps us a lot to just pin it to a specific core, which I wasn't aware that is possible, but apparently Unix allows you to tell each process which core to run on. Another interesting topic that wasn't existing before that was the deployment of client. Before that, we just had to deploy it on CDN, and that's it. Everything was online. Now we had to actually load it on the server. And one of the initial thought that we had was that we wanted to, in order to save like client and resources, we wanted to, for each render, to start a process, render it, load all of our code base, run the render, and then kill the process. We realized that very early that it wasn't going to work. So this is the reason that I said that we're sharing the same VM for all of the rendering. Because parsing and loading the code is very, very expensive, and it costs like maybe even like a 500 or 1 second just to load everything. And loading everything, as if you have a penalty for each rendering for 1 second, then yeah, you're not in a good place. Another important thing, not to hurt other teams, was not to tie the client to the server. So if we packed the client version inside of the Node servers, that would have caused every release that we needed to be deployed with the client. That was not something that we were willing to do. So we had to split those. The way that we did that is that we deployed all of the client code into our servers with using Chef, the same way that we do for other things. And Node actually doesn't care to load things dynamically. So right now, you have source code being deployed to the server. We're just using a path, and we're loading all of the client into our new process that was handling the rendering. And once you get a new version, you can just like kill that process and start a new one. One of the things that was difficult here is that we were not sure about the deployment and how fast it's going to be, and we had to test a lot, and in the end we managed to deploy of full client versions in about like maybe 15 minutes for like double or even triple digit number of servers. And an important thing is stability, because client people release stuff and we don't want them to kill anything, or at least we want to allow them to play with stuff on production. So we introduced a way that they can play with a version before they deploy it. So now they can override the version, we start a new process, we load everything to it, and then we run the code in it. The reason that we did it wasn't very performing, but we did that in order to allow them at least to experience how it's going to work in production. This was some of the things that will allow them to continually increase, to play around with their features and actually develop new features. And that's external resources is another important thing. Like the client downloads stuff from CDN. It also downloads stuff from Wix systems. And it's the same code base. Same thing that runs in the client runs in the server. But we don't want the client to access all of the URLs, the same exact URLs. So we want to access inside of the data center. So if a Wix system is talking to another Wix system, we prefer to work directly. Another thing is that user data is also the data that we download from the CDN needs to be downloaded again to the server side renderer servers. The way that we do that is that we have just one HTTP client that calls for each external resource, and we override it and we change the URLs to internal ones. This worked with some things. On the S3, like downloading stuff inside AWS, apparently is not very performing as you might think. I tried to access several things. I wasn't able to get consistent performance from it. At the end, the thing that worked for us was actually starting an Nginx caching server, and because of our files being immutable, it allowed us to decrease like time from 350 milliseconds to download a JSON to like maybe 20. So this was something that was very surprising because we were not prepared for that. And the most important, this is actually, if you're ever planning to do React rendering, you should implement chunked responses. It was a little bit tricky. I can share you some of the pains that we had with it, but it impacts the client significantly in a way that I was even surprised how significant was it, because client when it gets the first chunk, it starts to parse it and start to download stuff. So when you run render for React, that takes maybe, let's say, 500 milliseconds. In the meantime, if you're not returning anything to the client just doesn't do anything. Once you return the first chunk, even if it's you don't actually understand it, but the browser itself reads the chunk, and if it has scripts in it, it starts downloading it. If it has big amount of data, it also parses stuff with it. So the resource in themselves are let's say the browser itself downloads maybe like 20 or 200 images and a lot of things. Browsers are not downloading. I know if some people may think that if you were asking the browser to download 200 files, it will download them immediately, or at least issue a request for it. It doesn't happen. Chrome, I think, holds you at about like 5 concurrently, or maybe, let's say, 15. It changes. I can say something, and tomorrow it's going to change, and they're going to increase it, decrease it. You can't No. So one of the things that we, if while doing it, while getting the first chunk and actually returning data to the client and allowing to do something, it allows us to stretch the amount of resources throughout the time. So even if it wasn't supposed to be performing, it was more performing. So the first thing that you can do, and by the way, Node, it's extremely simple to do that. Once you get the first request and you have a template, just answer the head of the document immediately. Once you do that, the client can work with it and can start downloading, even like, for example, downloading Santa or React itself happens immediately when the head is returning. The body is being returned with the rendered HTTP, with the rendered HTML code in it. And when the browser gets that specific data, it already downloaded everything. It had enough time to start and downloading stuff. And this one, and it starts parsing it immediately, and the website will load faster. I'll conclude, I think, with this slide. I cannot say we had a lot of challenges, but I think the most hidden one were system challenges, because there are things that we don't consider when we start deploying a system. Like, for example, the number of servers that we have on server-side rendering, I think it almost doubled our number of servers in Wix. So we weren't sure how the processes, like everything, would work when we had when we started up. Like, how do you deploy stuff to 100 servers when the most you deployed was to 5 or maybe 10 servers at the same time? And this was things that were checked. And for example, the amount of money that we had to pay to AWS instead of what we paid so far. So, for example, with system, we actually added more features. For example, spot instances is being used heavily for server-side rendering. And eventually, I think the cost was reduced to like quarter of what we expected it to be, and this helped a lot. The supporting infra was also needed to be tested and work. For example, monitoring of all of that amount of servers. It wasn't something that we were sure that the system will hold. And apparently, when we had to test it and add improvement to it. And also the deploy process. If we had to deploy stuff for 15 servers, and now we have to deploy to 150 servers, and we wait, like, for example, 1 minute between deploy to deploy. When you have 15 servers, that's going to be 15 minutes. When you have 150 servers, that's not something that we need to happen. We can actually live with. So this was something that was optimized again and again. And thank you for listening.